All right, so really I'm sorry for that one. Yeah, we got disconnected. So it's really a pain in the ass. So even right now, it's keep on saying that your internet connection is unstable. So anyway, so can you guys hear me? Can you guys hear me clearly, or is it still stuttering? Hello, you guys there? Hello, guys. Hello, can you guys hear me or no? All right, so can you guys hear me now? Hello, hello, hello.
Yes, sir.
Ah, keep on saying your internet connection is unstable. Anyway, so pag na-DC pa rin tayo, okay, so since hindi na kasi maganda yung pagpalaging DC every 5 minutes, so hindi na siya, dito, hindi na siya maganda. Parang, basta, hindi maganda yung lagi na-interrupt. Okay, so, pag na-DC pa rin tayo mamaya, okay, so hanggang doon na lang siguro muna. Tutuloy na lang natin next meeting. Pero kapag okay pa naman hanggang part 3, so tapusin natin to kung matapos natin. Anyway, so for you to be able to know the polarity of the capacitor, so can you guys see my screen now?
Yes, sir.
All right. So let's say we have here a positive half cycle, so positive here, and then negative here. So as I'm saying a while ago, where is that one? We have this kind of polarity of the diode. Okay. So we're in if we have positive to positive and then negative to negative. So this uh, will become a forward bias, right? Guys.
Yes, sir.
Okay, so if we have a forward bias, then where is that one? We could say that this one is a closed circuit. So if this is closed circuit, then we have a complete, okay, loop of voltages here. Okay, so it will never pass through R sub L or load resistor. So as a result, if we have a closed loop here, so again, as I said a while ago, this capacitor will only charge if we have a closed loop here, okay, because that's the time that it will reach its maximum voltage. So again, for you to be able to know the polarity of the capacitor, okay, so just take a look on this one. Whatever is the side of this one that will pass the capacitor first, it's just the opposite. Okay, uh, it will be flip, or because here's the logic. Okay, so it will be charged positively here, and then it will discharge, okay, it will discharge negatively. Okay, so that is why whatever is the first sign here will be your sign here, and then whatever is the sign here will be your sign here. So as a result, our polarity now will be like this. So this voltage now is negative VC, or negative VMC rather. Okay. So as you can see, that is during the positive half cycle. But if it's but if it's during the negative half cycle, okay, if it's during the negative half cycle, okay, so negative is connected to the positive and then positive is connected to the negative. So as a result, this one will become reverse bias. So if this is reverse bias, then this one is an open circuit. So as a result, all of our voltages will pass through R sub L. Okay, and then as you can see, if it's an open circuit here, it will not charge anymore. Okay, so as a result, our VMC or our capacitor will discharge now its voltage. So again, when is the time that it will discharge? So it will discharge once it detects that the peak voltage, okay, of the VMC is lesser than V sub I. Okay. So I would like you guys to take a look on other examples on YouTube or on Google on how a capacitor works, because that's the time that uh, it will, okay, discharge if it uh, detects that it has a power loss. All right, so as a result, we have here negative VMC plus, oops, so V sub O is equal to negative V sub I, which is the sign of this one, okay, and then plus negative VMC. That is in this case. This one is negatively, yeah, this one is negative clamper. Okay. So V sub O is equal to negative V sub I plus minus VMC. All right, or negative VMC. Okay, so let's change this one. So let's make this like this. So this one now is positive clamp. Okay, the one that we've discussed a while ago. Okay, like this. So as you can see, just by inverting this one, just by flipping the diode, it will now make the circuit as a negative clamper. Okay. So this one is positive, just flip this one, it will now make it a negative clamper. So in this case, let's say during the negative, oops, yeah, this one is already correct. All right, so again, how will we know where we'll start? Is it during the negative or is it during the positive? So always start, okay, always start at a point wherein our diode here will become a closed circuit, okay, or our diode here will become a short circuit. So for us to have, yes, sir. All right, so for us to have a closed circuit here, we must start during the negative half cycle or at negative half cycle. So negative is connected to the negative and then positive is connected to the positive. So as a result, we have a closed loop here. All right, so I will just make this one closed loop for you to have a clearer view. Okay, so again, if we have a closed loop here, then that's the only time that it will, or our capacitor will charge. Okay, so again, whatever is the sign here, that is now the sign of our capacitor right here. Okay, so it will be charged negatively, okay, and then it will be discharged positively. Okay, so negative, negative, positive, positive. All right. So this one now has a polarity of positive VMC. All right. And then during the positive half cycle, so let me just erase this one. During the positive half cycle, we have here negative, positive. Okay. So during the positive half cycle, as you can see, positive is connected to the negative and the negative is connected to the positive. So as a result, if we have that kind of loop, this will become reverse bias. All right, so if this is reverse bias, then you can just simply say that this one is an open circuit. So all of our voltages now, or voltage input, will pass through R sub L. Wherein, if you're going to calculate for V sub O, okay, V sub O is equal to, so just base it on the polarity. So positive V sub I, okay, positive, and then positive VMC. All right. So as you can see, this one is a positive clamper because it only outputs positive voltages. Okay. So that's how you will know the correct polarity of our capacitor. All right. So again, always choose the cycle, okay, wherein we'll get a closed loop here. Okay, so whatever is that loop, let's say positive or negative. So whatever passes through this one will be the sign of this one. And then the sign of this one should be the same with the sign of this one. Okay, and then during the open circuit, then that's the only time that it will discharge its charge voltages. Okay. So did you guys get it so far? And how to know the polarity of the capacitor?
Yes, sir.
So first, dapat, ano ko ba isasama dito? Summarize. So first, you must have a closed loop. So during the closed loop, capacitor will be charged. Will charge. Ayan. Yan na lang. So dapat ito yung pinakauna yung gagawin. So first, you must know what polarity you're going to do first. So the first thing that you need to do is charge the capacitor. So for you to be able to charge the capacitor, okay, so you must have a closed loop. So if you have a closed loop, then that one must be a forward bias. Okay. So second, once the capacitor now is charged, then you must go to have, or you must now have an open circuit, closed loop, closed circuit. Yeah. And then open circuit right here. We're in capacitor now will discharge. Okay, and then for the polarity, so you should know that already. So I've already discussed what will be the polarity of your capacitor. All right. So first, look for a case wherein you'll get a closed circuit, and then of course during the closed circuit, that's the only time that your capacitor will charge. And then during the open circuit, then that's the only time that the capacitor will discharge. Okay, so that's the idea behind it. Are we clear so far?
Yes, sir.
All right. So just let me know if it's stuttering. Okay. Para makapag-stop muna ako and then yan, mabalikan natin. Anyway, so that's the idea behind positive damper. Okay. So let's have an actual example of positive damper circuit. So calculate the V out during the positive and negative cycle. Okay. So we have here a voltage input of 10 volts. So this one is peak to peak. So 10 volts positive and then negative 10 volts for the negative. All right. So here's the solution. Okay. So again, look for the opportunity wherein we have a closed circuit. So that opportunity or that case will be a negative half cycle. So why? Because we have here a sign of negative, which is connected to the negative, and then positive is connected to the positive. So we're in, this one will become a forward bias. So if it's a forward bias, then it will make it a closed circuit. So if it's a closed circuit, then that's the only time that it will charge or your capacitor will charge. So in this case, we have here a polarity of negative, okay, and then positive. Because negative here, positive. So it will be charged negatively and then it will be discharged positively. So as a result, this one is positive VC or VMC. VMC. Okay. That is during the negative. And then if you're going to take a look on this one, if it's short circuit, of course, all of our voltages will only pass through, or it will only loop here. Okay, it will not pass through our load resistor. So as a result, V sub O is equal to 0. And then capacitor is being charged. We're in, of course, the V sub I is 5 volts. Oops, why is it 5 volts? Did I made a mistake? Positive 5, 5. All right, so let me just have a quick correction. So this one should be 5 volts. Okay, so let me recorrect this one right away. Right, just wait a second. PowerPoint. So what light is that one? Where is it 10 volts? It should be 5 volts. Peak to peak of 5 volts. And then 5 volts, 5 volts. Yeah. Oops. Okay, so just wait a second. All right. All right, so we're now back. So can you guys hear me or is it stuttering? Do we have a good connection or no? Hello guys. Can you guys still hear me? Right, so internet connection is unstable again. So I think it's now back choppy. Okay. So sabi ni Mr. Daman, yeah, it's choppy. So most of you hear me choppy. So how about now? Is it now okay? Can you guys hear me now clearly? No, one device. Hello? Can you guys hear me? Are we clear now? Are we good? Hello? Naririnig niyo ba ba ako? Or is it still choppy? Yeah. All right, so I think we're back. So we got disconnected partially. So can you guys hear me now? Or is it still stuttering? Oh no, keeps on saying your internet connection is unstable. We're having now a problem. Still choppy, sir. So yeah, this is the problem when it comes to data connection, since a lot of people, millions of people, or even I think billions of people is using data connections. Of course, there's a lot of connection going here and there, and then as a result, we'll get disconnected from time to time. My God. So just let me know. I'll keep on talking. Okay. So just let me know if you guys can hear my voice clearly. So I'll keep on talking. So let me know if it's not choppy anymore. All right. So again, yeah, this is a problem. I think we now only have, yeah, I think we only have 3 meetings left, more or less. So 4 or 3 or 5, 3 or 5 meetings left. Not sure. So supposedly, we'll finish this topic today. But since we have this kind of problem or circumstances, I think we won't be able to finish it right now. So we'll see. Well, actually, there's 3 or 4 more. Okay, but the others are not that hard to explain or not really hard to understand. So the others can be a self-study actually. Okay, so this one is one of the major part. So this one is quite hard to understand. The clipper, the clamper, the Zener diode, the LED diode. What else? There's actually 2 more, but I forgot the other 2. So I think you have a total of 6 modules or 5 modules in finals. Okay, so we've only finished 1 module, so there's 4 more. Okay, but don't worry if we won't be able to discuss the say 3 modules or 2 modules, then I won't include that one to your exam anymore. So up to the part that we will finish only. Okay. Anyway, so can you guys hear me now clearly, or is it still stuttering, or is it still jittery or laggy? Hello? Or is it still choppy? Hello, guys. Oh, yes, sir. All right, all right. It's good. It's good to hear. All right. So again, I made the correction here. So your voltage input here should be 5 volts. Okay. So 5 volts positive and then 5 volts negative or negative 5. Okay. So during the negative half cycle, as you can see right here, we have here negative to negative and then positive to the positive. So as a result, this one will become a closed circuit. So if this is a closed circuit, then that's the only time that our capacitor will charge. So as a result, as you can see right here, we have here a negative and then positive here. So negatively charged, and then it will be discharged positively. Okay. So as a result, we have a positive VMC, right? So that is the sign of our VMC, okay, which is positive 5 volts. Okay, since that's the only uh, voltage that charge or that pass through our capacitor. So VMC is equal to V sub I or voltage source or 5 volts, since that's our V sub I. All right. And then during the positive half cycle, as you can see right here, we have an open circuit because positive is connected to the negative and the negative is connected to the positive. So as a result, we'll get an open circuit. So if it's an open circuit, then that's the only time that our capacitor will be discharged. Okay, so just you can simply remove this one and then just focus on the V sub I capacitor and then the R sub L. So if you're going to apply KVL, okay, you will have this equation. So V sub I, or positive V sub I, plus VMC, which is the polarity of our VMC, and then minus V sub O, because of course we'll get a voltage drop at this point. So if you're going to simplify this one, okay, you'll get V sub O is equal to V sub I plus VMC. Okay, it says your internet connection is unstable again. Are we still clear? Can you guys still hear me clearly? Or is it stuttering or choppy again? Oh, guys, are we still good or no? Choppy, sir. All right, all right. So choppy, choppy. So data, when it comes to uploads, data connection is not that reliable. So maybe this is reliable for a short time, but not for the, say, for 2 hours or 3 hours. So from time to time, it keeps on having a problem or interruption. Anyway, so just let me know. All right. Okay. So it's good to know that it's okay again. So again, as I said a while ago, if you apply KVL, you'll get this equation, and then just simplify this one, you'll have this another equation wherein V sub O is equal to V sub I plus VMC. So if you're going to solve for the voltage output at this point, so V sub I is equal to 5 volts, and then VMC is equal to 5 volts. So that's the value during the negative half cycle, wherein it was charged positive 5. Okay, so if you're going to do the math, so 5 volts, 5 plus 5 is equal to 10 volts, right? Or you have, you can have another calculation wherein twice of the V sub I or twice of the V sub I, wherein you'll get the same answer. Okay, so if you're going to take a look on this one, you have 5 volts and then 10 volts. So basically, it's twice the peak voltage of the positive. Okay, so from positive 5 to negative 5, it was shifted above the ground level, wherein, of course, positive 5 and then another positive 5 will result as positive 10 volts. Okay, so that's how we've got this answer. Okay, so any questions so far? Answer. All right, so I will leave this one for 1 minute to the others who are still, processing. How did we get it? So just let me know once it's okay. So I can uh, give you a minute only, of course, since we now only have 8 minutes left. So just let me know if you have a clarification or concern or a problem in understanding or in analyzing the circuit for the solution. Right, that's it. So 1 minute is up. So let's move on to the next one. So for sure, we won't be able to finish this one today since we're having a bad connection. So I decided not to finish it today. So we will just finish it next meeting. All right. So we will stop on the part only. Anyway, so we still have 7 minutes. So let's see if we can finish the negative clumper circuit. So negative clumper circuit is the opposite of this one, of the positive clumper. So negative clumper will be below the ground level or below the 0 volts. Okay. So a resistor still composed of the same components, a resistor, a capacitor, and then a diode, wherein it shifts the output signal to the negative portion of the signal. Okay. So the only thing that is different on this one, on why it become negative clumper, is the polarity of the diode. So before we have negative, positive, but right now we have positive and negative. So it was just simply inverted, okay, or flipped. Okay, so it says here again, your internet connection is unstable. So are we still good? Can you guys still hear me? Is it still clear or no? Yes, sir. Okay, that's good. So again, if you understood completely the positive clumper, okay, then you will understand the negative clumper at the same time. Because all you need to do is, reverse everything. So positive clumper accepts or moves the voltage above the ground level, and then for the negative clumper, accepts below the ground level. Wherein again, the only difference is this diode. Okay, it was just flipped. All right. So this is just another example wherein I want to show to you guys that we have another kind of waves. So we're always using sine waves, but we still have another 3 other waves. Okay, the other one is a square wave, and then the other 2 is a triangle wave, and then the sawtooth wave. Okay, so sine wave is very familiar, and then square wave is also familiar, and then triangle is not that much. At most, sawtooth is not used at all. Okay. So sine and square is quite familiar, but triangle sometimes only. Okay, this will only use if you want to get the peak-to-peak voltage. Okay, and then square wave if you want to get when is the time that it shifts. Okay, from positive to negative. And then sine wave is actually the overall. Okay, and then sawtooth is if you want to get the middle, okay, voltage when it shifts from positive to negative. But actually, in reality, the sine wave covers everything: the square, triangle, and the sawtooth. And anyway, I just would like to say that there's another or there's other kind of waveform, okay, other than sine wave and then square wave, which is a triangle and then sawtooth. Right, so let's go back with the negative clumper. So again, this is the circuit of the negative clumper. So during the positive half cycle, the capacitor gets charged to its peak value, V sub M, or VMC, okay? And then the diode is forward biased and it conducts. So during the negative half cycle, the diode gets reverse bias and gets open circuited. So the output of the circuit at this moment will be V sub O is equal to V sub I plus VMC. So I won't go on the step-by-step process of this negative clumper anymore because it's just the same with the process of the positive clumper. It's just that just have to interchange this one, okay, and then reanalyze everything again. Then you will see that all right. So this one is the negative clumper. Okay, so just basically the same is everything is the same. It's just that it was shifted below the ground level. So hence the signal is negatively clumped as shown in the above figure. Okay, this one. So the output signal changes according to the changes in the input, but shifts the level according to the charge on the capacitor as it adds the input voltage. All right, so I decided to stop right here for now. Anyway, so I think we can still finish this one. 2 minutes. Okay, we will try. So take a look on this one during the positive half cycle. So during the positive is connected to the positive and the negative is connected to the negative. So during the positive half cycle, we have a short circuit or a closed circuit. Okay, wherein if we have a closed loop here, then all of our voltages will only loop here and then it will not be able to pass through our V sub O or our load resistor. So V sub O is equal to 0 volts. So again, if it's short circuit, then that's the only time that our capacitor will be charged. So positive here and then negative here. So it will be charged positively and then it will be discharged negatively. So that is why we have here a sign of negative V sub I or negative V. Okay. And then during the negative half cycle, of course, it is now open circuit. And then if it's open circuit, then that's the only time that it will be, or that's the only time that our capacitor will be discharged. Okay. So if this is open circuit, so you can analyze this circuit with the use of KVL, and then you will get this equation. And then simplified further, you'll get V sub O is equal to V sub I plus VMC. And then, or you can have V sub O equals to negative twice of the V sub I or the negative twice of the V sub N. So yeah, that's how you get, or that's how we've got the wave here, okay, below the ground level. So we will stop right here for now for today. We will just continue the rest next meeting once everything is okay. Since Converge is really having a hard time right now. They're still fixing some of the posts or the line. Anyway, so goodbye for now. And then please try to understand the